Hello friends, Diane here, and I'm so happy to see you. Today, we're going to be talking about patterns we find in multiplication. I've been thinking about some of the multiplication and division problems we've solved together and some of the strategies you've used, especially the skip counting strategy. I wonder if we were to look at a hundreds chart, if we could find patterns and relationships between multiples of certain numbers. Finding a pattern with multiples can help us better understand multiplication and help us learn our facts. Do you want to try? Great. Before we get started, let's review what we know about the words multiples and factors. Let's use a Frere model to help us out. Are you ready? Let's get started. To make our Frere model, you will need a piece of paper, a pen, pencil, or a marker. I'm going to get my supplies. You go ahead and do the same. Now that we have our supplies, let's begin to make our Frere model. Let's take a piece of paper and fold it in half, hamburger style. Then we're going to fold it in half again to make 4 equal rectangles. Then in the corner of our paper where all sides are folded, we'll fold down a small triangle. When you unfold your paper, the folds should look like this. Does yours look like mine? Okay, great. We are going to write the words multiples and factors in the center diamond because these are the words we need to understand more about. Then, in the upper left rectangle, we're going to define each term. So let's write the word definitions here. In the upper right triangle, we're going to provide an example of multiples and factors. So let's write examples here. Then, in the lower left rectangle, we'll provide a non-example or what multiples and factors are not. So, write non-examples here. And finally, in the lower right rectangle, we'll draw a picture to help us visualize what multiples and factors are. So let's write the word picture here to remind us of what we're supposed to do. Now, we're going to define we got 2 words, multiples and factors together. So let's write the definitions in our upper left rectangle. To begin, a multiple is the result of multiplying a number by another number. Factors are the numbers we can multiply together to get another number. I'm going to give you some time to write these definitions in your Frere model. As we learn more about multiples and factors in today's lesson, you will be able to add examples, non-examples, and draw a picture to share your growing understanding of multiples and factors. All right, so imagine you have a package of juice boxes. Each package has 10 juice pouches in it, or 1 times 10 equals 10. So, how many would 2 boxes have? You say it with me? 2 times 10 equals 20. What about 3 boxes? Great job. 3 times 10 equals 30. So, what pattern did you see? Right, each multiple has a 0 in the ones place, and the number in the tens place increases by 1. They're all in the same column. Using that pattern, could you tell me how many juice pouches would be in 6 boxes? Right, 6 times 10 equals 60. Imagine counting by tens 6 times. How about 8 boxes? Right, 80. I'm counting by tens 8 times. What about 10 boxes? Great, 10 times 10 equals 100. I'm counting by tens 10 times. Let's try multiples of a different factor. Let's try multiples of 5s on the hundreds board. Can you count with me? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. What do you notice about the multiples of 5s and 10s? What was that? 10s and 5s share some multiples? I noticed that every second multiple of 5 is also a multiple of 10. That's really interesting. I wonder why that happens. Are the numbers 5 and 10 related to each other? What do you think? Not sure? Let's look at a representation using these dots. What do you notice about one group of 5 and one group of 10? That's right. When you double 5, you get 10. So 2 5s equals a 10. Let's see how that looks on a hundreds chart. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Every 2 5s equals a 10. So will doubling the number of times I count by 5s equal the same number of 10s? Let's try it. 3 times 5, so I can count by 5s 3 times. 5, 10, 15. If I count 3 more times, that should be 3 times 10. So 20, 25, 30. Yeah. So what about 4 times 5 and 4 times 10? I need to count by 5s 4 times. 5, 10, 15, 20. Then another 4 times to double it. 25, 30, 35, 40. If 5s and 10s have that relationship, what about other numbers that have the same relationship? Do they follow the same pattern? What if we try 2s? Let's count and highlight all of the multiples of 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. What did you notice so far? Yes, they follow a pattern. They are all in the evens column. Because they're even, there is a 2, a 4, 6, 8, or 0 in the ones place. What number do I get if I double 2? What was that? Right, 4. 2 and 4 have the same relationship as 5 and 10. So should they share some of the same multiples? Let's find out. Let's use this pattern to fill in the hundreds chart with multiples of 4. We already have some of the multiples of 2s highlighted, so let's finish that up. We know that doubling 2 will get us 4. So every 2 multiples of 2 should be a multiple of 4. Let's try it. 4, 8, 12, 16, 20, 24. What do you notice? Yeah, the multiples of 4 are making a pattern. Can you keep it going? Nice. Could you use this pattern to answer some multiplication questions? About 5 times 4? Maybe 6 times 2? What about 8 times 4? 7 times 2? Right, and last one, 9 times 2. Great job, mathematicians. Do you think there could be other patterns on the hundreds board with different numbers? What about maybe 3 and 6? Or 4 and 8? There are so many patterns to find with multiples. We don't have time to look for them today, but maybe you can explore them on your own. Thanks for helping me today. We learned that we can show patterns of multiples on a hundreds chart. Thinking about these patterns and relationships between multiples helps us better understand multiplication and learn our facts. Mathematicians, you did a great job today. I hope to see you again soon. Until next time, bye y'all.